Hello everyone and welcome back to physics class. Today we're going to be doing some review of fundamental mathematical concepts that we use very often in physics. Today we're going to be looking at the basics of trigonometry. Specifically, we're going to be focusing on the Pythagorean Theorem. So when we start talking about trigonometry, we actually have to understand angles and the Cartesian plane first. This part here, this one would have your 0 degrees. That would be the angle associated with the x-axis on the right-hand side. The further up you go, if you go counterclockwise, that's the direction we always do to read our angles. We would find that this up here is 90. Go back down, we have 180 degrees here. Continue, we have 270 degrees here. And then going back up, when you do the complete circle, it ends up being 360 degrees. So let's do an example. Let's say we have this angle that we want to find here. This is our unknown, this is our theta. And let's say we know that this angle in here is 41 degrees. We need to use the information on this chart here, which remember, these will not be always given to you. You need to memorize those 4 or 5, I should say, angles. And we can use that information to find what our theta is. So in this case, it's pretty simple. We have our angle is in quadrant 3. Now, we know that to go from here to here is 180. And we have this extra 41 degrees here. So all we have to do is add that up together. So our theta for this case will be 180 plus 41 degrees, which will give us 221 degrees. Let's do another example. Let's do this green one here. So we know that this angle in here is 27 degrees. I want to know what that angle in there is. So I want to know this big angle in here. So when we are in quadrant 4, we're actually going to take this angle here and we're going to subtract 27 from it, because we don't know what this angle is in here. If we knew what this angle was in here, then I would just take 270 and add that little bit, but we only know what this one is. So we want to find the difference. So for this one, it'll be 360 minus 27, which should give me 333 degrees. Now I want you to try to do this yourself. Take a moment, pause the video, and try to find this angle theta here on your own. Awesome. So let's go over this example here. We know that this whole angle here is 180 degrees, this whole thing, this straight line right here. And we know that this angle in here is 72 degrees. We want to find this angle here. So we're going to do another subtraction. We're going to take 72 away from 180. And that will leave us with an answer of 108 degrees. So if you got that answer, then that is correct. So now let's look at the Pythagorean Theorem. Now remember, the Pythagorean Theorem is only used for right angle triangles, and it's only used for when we know at least 2 of the sides. So we remember, A and B are our legs of the triangle, and C is the hypotenuse of the triangle, meaning that it is the length across from the right angle. Now, our formula that we would be using would be C squared is equal to A squared plus B squared. So we can find any length of the triangle using this formula as long as we have the other two lengths. So let's take an example. Let's say we have this triangle in here, and we know that our B is equal to 4 and our A is equal to 3. We want to know what our C is. So we would move this around here, or actually we don't even really need to move this around because we're looking for our C. So C squared is equal to A squared plus B squared. So 3 squared plus 4 squared is equal to C squared. Now remember, you want to do the squares first. So 3 squared is 9, and then 4 squared is 16. Then we're going to want to add those up. So 9 plus 16 gives me 25. Now, to get rid of this square on the C, we need to take the square root. The square root and the square will cancel each other out to give us just C. But since we're doing it to one side of the equation, we need to do it to the other side as well. So the square root of 25 will give us 5. So the answer to the question here is that C is equal to 5. Now, I want to do another example. Let's take this triangle right here. So this side is equal to 3. Here's our right angle. And this side is equal to 5. We want to know what this side is. So if we wanted to isolate for one of our legs, let's say that this is B that we're looking for, we need to maneuver and manipulate this formula first. So let's write out C squared, whoops, it's not plus, it's equals. C squared is equal to A squared plus B squared. We need to get B squared to be by itself on one side of the equation. So what we're going to do is we're going to remove our A squared and bring it to the other side. So then it becomes C squared minus A squared is equal to B squared. Now I'm just going to rewrite this formula so that my B squared is on the other side. And there we go. So now we can start. B squared is equal to 5 squared minus 3 squared. 5 squared is 25. 3 squared is 9. So 25 minus 9 is 16. Take the square root of both sides. And we get B is equal to 4. All right, now I want you to try this example yourself. We have a right angle triangle here. We have the length of our hypotenuse. We know that it's 10. And the length of our A side is 6. So pause the video, take some time, and I want you to find what the length of B is. All right, so let's take a look at this together. If we remember from last time, when we were looking for the length of one of our legs, we had to manipulate our formula. So because we wanted our B squared to be isolated, we took our A squared, brought it over to the other side of the equation. It became C squared minus A squared is equal to B squared. Then from there, we were able to plug in our values. So C is 10, and then our A is 6. So 10 squared is 100. Our 6 squared is 36. When we subtract 36 from 100, we will get 64. And then the last step is to take the square root of both sides. Whoops, I should not have written that because I just took the square root. So b will be equal to 8. Thank you for listening. I'll see you next time when we start talking about SOHCAHTOA.